Hello everyone, welcome to our weekly session. Today we will talk about practice project lesson number 8 in data wrangling section. Remember your data wrangling project, creating analytical data set? Well, this is step 2. In this project, we will use the data set you created or you will create during that project. The idea is that we have a bit store chain with 13 stores. This year, they decide to open a new store, and we will try to use the dataset we created during the last project to find out the best city for the new store based on the predicted yearly sales. Let's go to Alteryx. If you worked on the analytical dataset project, you should be familiar with this dataset. This is the clean dataset you prepared or should prepare during the last project. As you can see, we have our target variable, sales, we have 2010 population, we have land area, household, population density, and total families. And we have the data on city level. Also, we have data set that has the potential cities to open the new store. We have the demographic info about each city. We have the same information, but we don't have the sales here. Okay, so the general idea here that we will use the first data set to build a linear regression model to predict the sales per city. And then we will apply the model on the second set to predict the sales for each city here and to find the best city to open the new store, which is the city has the highest sales. Anyhow, we need to apply a few criteria on the second data set. We will talk about this later on. Now, as usual, before doing anything in Alteryx, we should use select or autofill tool. So we can select the right data type for each variable. I'm gonna use autofill tool. Now, let's go back to the project details. Step number 1, build a linear regression model. There is an important note here regarding the outliers. During the last project, you worked on finding the outliers and you suggested which outliers should be removed from your dataset. Now, for the sake of this project and to get the same result from everyone, we will consider GLET as our outliers and remove it from our dataset. So let's use filter. Okay, let me find. Okay, let me take it from here. So city doesn't equal. Okay, okay, we have 10 rows in our dataset. Now, linear regression model. When we need to build a model, we need to explore our data. to get a clear picture about the variables and the relationship, the correlation between the variables. We can use scatterplot in data investigation group. So we can see if there is a linear relationship between the target variable and the predictors. Okay. The target variable and the first predictor 2010. I'm gonna add browse tool and I'm gonna uncheck the smooth line. Now the next variable, land area. Household. Density and total families. So let me run the workflow. Now I used copy paste to avoid doing the configuration every time. It's easier this way. You can save some time. Okay, a few more seconds. Okay, it's done. So total sales and 2010 population, we can say we have a linear relationship here. Again, we have a linear relationship, not very strong one, I believe. Anyhow, uh, households and sales, we have a linear relationship. Same thing here between population density and sales. Again, sales and total families. So we can say that there is a linear relationship between the all predictors and the target variable here. Okay, another to check the relationship is to use association analysis to check the correlation between the variables. I'm gonna delete these tools. I don't wanna run it every time. I'm gonna add association tool here. Check all the variables and I'm gonna add browse tool after the report. Run it again. Uh, I only add a browse tool after the report outcome because I'm not sure why, but the interactive report always cause an error on my machine. I'm not sure what's the exact reason. Anyway, that should do our job here. Okay, this report contains a correlation matrix or correlation table that shows us the correlation between all the variables. Let, let us check the target variable, for example, the sales one. Okay, see, this confirm our finding from the scatter plots. We have a strong correlation between the target variable and the rest of the predictors. 89 here, 67, 90, 87. With the land area, we have a negative correlation, and it's not very strong one. Anyhow, what about the correlation between the predictors? I mean here. Let's take example the 2010 population. It has a very strong correlation with the households, with the population, and with total families. We call this case or scenario multicollinearity. Uh, Let me show you the effect of this case on a predictive model. I'm, I'm gonna add a linear regression model here. Target variable is sales. I'm gonna choose all the available predictors. Gonna add browse after report. Okay, let me run my workflow. We should a good p-values here since we have a strong correlation and the predictors, but this is not the case here actually. Okay, we're done. See, we don't have a good p-values here, and the reason behind that is what we called earlier multicollinearity. It's when the predictors are highly correlated with each others. Uh, this makes our variables look basically insignificant, while in fact they are significant. Let's go back to our association tool. Okay. When we check our predictors, we can see that population 2010, household, population density, and total families are highly correlated with each others. Only land area doesn't have a high correlation the other with the other predictors. So here is only to choose one or two out of the four predictors to include in our model, but we don't know which one is better to be used in our model. We have more than one way to find out. I will show you two ways. First, we can run four different models. Each model depends on one of the predictors, and then compare all the models. The second way is to use a stepwise tool, which give us the best model available to use. So first, let me delete this tool. Now, linear regression. I'm gonna add report after. So, sales. Remember, I'm gonna have correlated predictors. So 2010 population. I'm gonna choose the land area. Copy paste. Now I'm gonna check to households. And I'm gonna change it to population. Let me check this one again. Yeah, I did it correctly. So the last one, total families. Now I have the four models. I'm gonna use the second way, which is using stepwise tool. This is pretty straightforward. Uh, Connect the model that has all the predictors and connect the original dataset. Add browse after report. Now I'm gonna run it. So remember the stepwise tool. This tool is gonna try different combination of variables until it gets the best model available, the best p-values, let's say, or best adjusted R-squared. Now we're gonna compare the result here, and we're gonna choose the best model out of the four here, and then we're gonna compare it to the stepwise model. This is gonna take few seconds more. We're running for 5-6 models. Oops, finally. So I'm gonna use adjusted R-squared to compare the models here. So for this one, 2010 population and land area, we have adjusted R-squared 0.82. Land area household, we have 0.52, not so good. For this one, 0.77 land area population density. It's a good one. I believe this is the best one out of the four. 0.886 land area and total families. So I'm gonna choose this one as my best model. Let me delete the rest. So let me check the stepwise result. Oh, I'm sorry. I should add browse after report, so I have to run it again. I'm sorry about that. It's gonna take few seconds. Okay, we're done. So let me see. Uh, this is interesting. This tool gives us 3 predictors: land area, household, and total families. And it has a better adjusted R-squared, 0.92. Okay, anyhow, I'm gonna stick with this model, the, the one with the total families and area land, because this is the idea behind this project, to try different models manually and not to use the stepwise. So anyway, I just wanted to show you how to use the stepwise tool. Now, we have our model, and we can use the score tool to predict the sales for each city. But remember, the store should be in your city. So we should remove the current cities or the cities that already have stores. We can use join group, join tool. I'm gonna use it like this. So I'm gonna use city to join the two dataset. Okay, let me run it again. So we're gonna have three outputs here. Uh, the R output is gonna have the records from this dataset that excluded the records from here. So we need the R output. We need only these records to apply our model on. So see, I'm gonna show it to you now. In this data set, we have 99 records, while here we have 11 records. The R output, 88 records, which is 99 minus the 11. Anyhow, to apply my model, I can use score tool, predictive score tool, output to the model input and the R output to the data input. I don't need any configuration here. I just need to run my model. So one more remark about this project. Okay, let me go here. About the criterias we need to apply. Not gonna discuss the competitors and the population criterias because part of it related to the first project. Okay, we're done here. Just let me go back here. So part of this criteria is related to the first project where you need to clean these data sets. It's pretty much straightforward. Once you clean the data, you can use filter tool and join tool to apply the required criteria, then use join tool to between the dataset and the demographic set. Anyhow, now we have okay. Now we have our sales prediction for each city. Remember, we need to find out the highest sales. So we can use simply sort tool X. Of course, you can change the name X to a better name like sales prediction or total sales or whatever you want. I'm gonna use descending. I'm looking for the highest sales. I'm gonna run this workflow for the last time. So we build our linear regression model here. We have a list of cities that qualify to be the location of the new store here. We use the score tool to predict the sales, and now we're gonna find which city has the highest sales. Okay. 305013 Laramie City. So that's our answer for this project practice. We're done today. I'm gonna take your question if you have any, but first let me stop the broadcasting and then I'm gonna take your questions.